How do you make a better rotary telephone? You can think hard about the problem, but the likely answer is you don't make a better rotary telephone. You build an entirely new type of device. The same kind of question ran across Steve Jobs' mind before. How do you make a better human-to-hardware interface? It wasn't another keypad, nor was it using a stylus. He even stated it in the 2007 keynote. Much as the dial pad replaced the rotary dial, the human finger became the replacement interface to the fixed keyboard. Make all the fun you want of the current kludgy, janky wearable tech software hardware ecosystem, but what you're witnessing is the start of a new type of computer class. Bell's law of computer classes, of Gordon Bell, is a principle stating a new class of computer emerges roughly each decade by different factors, such as pricing, environment, network connectivity, and form factors. The principle stems from Moore's law, which observes transistor density doubling every 2 years. It has manifested in various computing platforms over time. Yet the real struggle in jumping classes is starting from a low, unrefined point after a highly polished endpoint. Spot the patterns in a new rising class of computers. An early tell is when hardware is sold at near cost, profit comes from ongoing service. Often an incumbent company reports rising revenue cost and decreasing sales. Something is stagnant, and as a result, a new way to extract value is brought forward. Next step, to poach talent away from competitors or outright acquire them. You have OpenAI snagging more than 24 Apple engineers in 2025 to power its AI hardware ambitions, and Amazon scooping up Bee, an AI wearables startup known for its conversation recording wristband. What the future holds, each class thrives in environments where previous classes were impractical. The earliest PCs were no match to their current counterparts. Give it time and people will begin to see large improvements. And with this expanding time comes newfound opportunities. Real-world implementations start to rear their head rather than being a novelty. A new type of computer class arises, not just because it looks different. It arises to resolve friction points, not solvable by the current architecture. The early classes of computers were more about price-performance improvements. Then came addressing accessibility and cost to unlock computation from prohibitive price tags. Early computers were too expensive, so time-sharing access was a valid business model. Now, no one is time-sharing your iPhone. The new class of computer contains a different form factor while taking advantage of remote computation to create new context about a live environment. They make use of outsourcing the current technological limitations while playing with a new interface. It is the emergence of broader patterns for an AI augmented reality world, a world of new contexts surrounding your environment and enabled by remote AI. Examples include Rabbit R1, Apple Vision Pro, despite its flaws, Humane AI Pin, despite its failure, Meta's Ray-Ban glasses, enabled home care like Tesla Optimus. Expect to see ambient computing of always-on, invisible interfaces where processing is split between local and remote hardware. These hybrid, cloud-enabled devices will adapt to an environment automatically. They don't demand your attention like a smartphone would. Rather, they anticipate it. They will likely stay with us until the next architectural breakthrough makes distributed processing obsolete and acceptable battery usage reaches an accessible price point.